Download this code from codegive.com, link in the description below. Setting up Ford Rs gauges using an Arduino Uno can be an exciting project for car enthusiasts and DIY electronics hobbyists. This tutorial will guide you through the process of interfacing Ford Rs gauges with an Arduino Uno, including the necessary wiring, components, and sample code. What you will need: 1 Arduino Uno, the main microcontroller board. 2 Ford Rs gauges. For this tutorial, we'll assume you are using a standard set of Ford Rs gauges, like speedometer, tachometer, and fuel gauge. 3 breadboard and jumper wires, for connections. 4 resistors, if necessary, to limit current to the gauges. 5 power supply, depending on your gauge specifications, this might be needed. 6 potentiometer, for simulating inputs, like speed or RPM. 7 multimeter, to measure voltage and ensure correct connections. Understanding Ford Rs gauges. Ford Rs gauges typically include: speedometer, measures vehicle speed. Tachometer, measures engine RPM. Fuel gauge, indicates the fuel level. These gauges usually operate on a specific voltage, often 12 V in cars, and may require special handling to interface with an Arduino. Wiring diagram. Here's a simple wiring diagram for connecting one gauge, example tachometer, to the Arduino. 1 tachometer wiring. Connect the positive input of the tachometer to a PWM capable pin on the Arduino, example pin 9. Connect the ground of the tachometer to the Arduino GND. If necessary, use a resistor to limit current. 2 potentiometer wiring, simulating RPM. Connect one terminal of the potentiometer to 5V on Arduino and the other to GND. The middle terminal, wiper, connects to an analog pin, example A0, on the Arduino. Repeat similar connections for the speedometer and fuel gauge as necessary. Sample code. Here's a basic example code to read the potentiometer value and send it to the tachometer gauge. CPP / define pin numbers. Const int tachometer pin equals 9 / PWM pin for tachometer. Const int pot pin equals A0 / analog pin for potentiometer. Void setup. Pin mode, tachometer pin, output, / set tachometer pin as output. Serial.begin, 9600, / start serial communication. Void loop. / read the potentiometer value, 0 to 1023. Int pot value equals analog read, pot pin. / map potentiometer value to appropriate range for tachometer, 0 to 255. Int tach value equals map, pot value, 0, 1023, 0, 255. / output PWM signal to the tachometer. Analog write, tachometer pin, tach value. / print values to the serial monitor for debugging. Serial.print, potentiometer value. Serial.print, pot value. Serial.print, tachometer value. Serial.println, tach value. / delay to see changes. Delay, 100. Explanation of the code. 1 pin definitions. The tachometer pin is defined as 9, which will output PWM signals. The pot pin is defined as A0 for reading the potentiometer value. 2 setup function, initializes the tachometer pin as an output and starts serial communication for debugging. 3 loop function. Reads the analog value from the potentiometer. Maps that value from the potentiometer's range, 0 to 1023, to the tachometer's PWM range, 0 to 255. Outputs the mapped value to the tachometer using analog write. Prints the values to the serial monitor for monitoring. Testing and calibration. 1. Upload the code. Upload the code to your Arduino Uno. 2. Simulate RPM. Adjust the potentiometer and observe the tachometer gauge's response. Ensure it moves in accordance with the potentiometer setting. 3. Calibration. You may need to calibrate the mapping function based on your specific gauges to ensure accurate readings. Conclusion. This tutorial provides a basic framework for interfacing FORDARS gauges with an Arduino Uno. You can expand this project by adding more features, such as reading actual vehicle data via OBD2, implementing more gauges, or using other sensors. Remember always to check the specifications of the gauges you are using to ensure compatibility with the Arduino. Happy tinkering!